Hello everyone. Welcome back to the Archive Radio Show. Today is Thursday, March 19th, 2026. I am your host, Ichino Ani. I am so excited to be here with all of you today. Were you ready to learn something super cool together? Let us dive right into today's trending article from the fascinating world of human-computer interaction. The title of the paper is Thermopneumatic Pixels for Fast, Localized, Low-Voltage Touch Feedback. The code is chips achieve work downside 603.16,750 round. Now that is quite a mouthful, is it not? But do not worry at all. I'm going to explain it very simply, just like we are in a fun science class. Have you ever played a video game where the controller rumbles in your hands? Or maybe your smartphone buzzes when you get a message. That is called haptic feedback, or touch feedback. It is a special way for computers to talk to us using the sense of touch. Right now, most of our devices use tiny motors that spin around to create those familiar vibrations. But engineers and scientists want to make touch feedback even better. They want to create displays where you can actually feel bumps from textures right on the flat screen of your device. Imagine sliding your finger across a completely flat piece of glass and suddenly feeling a physical button pop right up to meet your finger. But there is a big problem that this paper is trying to solve. Making tiny, strong, and fast touch pixels is incredibly difficult. Right now, the technologies we have are not quite perfect for everyday use. Let us compare this new idea with other older technologies. First, we have electromagnetic motors, which are very similar to the ones inside your game controllers. These motors are really great, but as you try to make them smaller and smaller, they stop working well. They get way too hot, and they are quite bulky, making them very hard to fit into thin devices like slide-wet. Then there are electrostatic methods. These can stretch and move really fast, but they need thousands of volts of electricity to work. Using 1,000 volts right near your sensitive skin is very scary, and it requires huge, complicated electronics to keep you perfectly safe. Finally, we have traditional thermal actuators, which use simple heat to create movement. These are safe and easy to make, but they are incredibly slow. It takes several seconds for them to heat up and cool down, which is way too slow if you want a snappy button click. So, what is the magical solution these clever researchers came up with? They invented something called Thermopneumatic Pixels. Let us break that big science word down together. Thermo means heat, and pneumatic means air. These smart engineers trapped a tiny amount of air inside a small sealed pocket. On the top of this pocket is a soft strip, rubber skin. Inside the pocket, floating right in the middle of the air, is an extremely thin piece of wire. This wire is incredibly thin, almost like a delicate piece of spider silk, and they send a tiny bit of electricity around 10 volts. Through that delicate wire, it heats up super fast, because the wire is so incredibly thin. It transfers its heat to the trapped air almost instantly. And as you might know, when air gets hot, it expands and takes up more space. This expanding air pushes up against the stripy rubber skin, creating a little bump that you can clearly feel with your finger. And when your electricity turns off, the wire cools down instantly, and the bump magically disappears. This whole process happens in just a few milliseconds. That means it is incredibly fast, just like pressing a real physical button. And the absolute best part is that it only uses very low voltage. So it is completely safe to wear right on your body, or also super easy for factories to manufacture. Our researchers built them using simple layers of cheap materials, kind of like making a delicious multi-layered sandwich. They just layer a flexible circuit board, some tape, and some rubber, and boom, you have a fully working touch pixel. During their testing phase, these tiny pixels could push up with over 1 Newton of force. It is more than enough strength for your finger to feel clearly. Let us talk more about how they actually tested these amazing pixels. The scientists put the pixels on a special measuring machine to see exactly how fast and how hard they could push. They discovered that the bump responds in just 5 to 100 milliseconds. That is faster than the blink of an eye. They also tested how long the device could last by making it pop up and down over 54,000 times. And guess what? It never broke down and it kept working perfectly. This is extremely important because our phones and gadgets need to last for years without breaking. Some people might worry that using heat would make the device too hot and uncomfortable to touch, but the researchers measured the temperature on the surface of the skin, and it only went up by about 4 degrees Celsius. That is basically the same amount of heat that your finger naturally transfers when you touch something. So it is completely comfortable to wear against your skin for a very long time. Right, so how can we actually use this amazing technology in the real world? I have 3 very specific and exciting application examples to share with you today. First, imagine a smart wristband or smartwatch that helps you navigate without ever looking at a screen. Let us say you are riding your bicycle or walking in a busy new city. Looking down at a bright map on your phone can be very dangerous. With these Thermopneumatic Pixels built directly into the strap of your watch, it could gently tap different parts of your wrist to guide you if you need to turn left. The pixels on the left side of your wrist will quickly bump up and down. If you need to stop, they might all press down at the exact same time, because these pixels use low voltage and are extremely flexible. They fit perfectly into wearable clothes and everyday jewelry. This would make finding your way around much safer and completely hands-free. Second, let us think about flat tile lens in our everyday lives. Today, where car dashboards, microwaves, and tablets are completely flat pieces of shiny glass. When you are driving a car, it is very hard to change the radio station or turn up the air conditioning on a flat screen without taking your eyes off the road. You simply cannot feel where the invisible buttons are. Yet if we apply this amazing technology to a car dashboard, the screen could actually grow physical buttons exactly when you need them. When you open the radio application, small rubber bumps instantly pop up to guide your fingers to the volume controls. When you close the application, the bumps completely vanish, leaving the screen perfectly smooth and flat again. This would make driving so much safer for everyone, and make our modern touch devices way more accessible for people with vision problems. Third, this technology could completely change the world of virtual reality and augmented reality. Right now, where you put on a virtual reality headset and pick up a virtual apple, or hand just closes on completely empty air. It really ruins the wonderful magic of the game. But imagine wearing a lightweight gaming glove, lined with thousands of these tiny Thermopneumatic pixels. When your virtual hand touches a virtual brick wall, the pixels on your fingertips instantly inflate to push against your skin. You would actually feel the hard, rough texture of the digital bricks. If you held your hand out to catch a virtual raindrop, you would feel a tiny, localized tap exactly where the digital water hits you, because these little actuators are so small and cheap to make. You could line entire gloves or even special shirts with them. It would make virtual worlds feel incredibly real, without needing heavy battery packs or scary high-voltage wires. It is just so wonderful to think about all the amazing things what brilliant engineers are inventing for us every single day. This paper clearly shows us that sometimes the very best solutions come from combining simple things, like heat and air in entirely new ways. The researchers even did tests with real human volunteers, and almost 96% of the time, the volunteers could accurately feel exactly which tiny pixel was poking them. That completely proves the technology really works, and it is ready to start moving out of the laboratory and straight into our homes. Well, everyone, that is all the time we have for our show today. I hope you enjoyed learning about Thermopneumatic Pixels just as much as I absolutely loved explaining them to you. Please keep staying curious, and always keep exploring the wonderfully fascinating world of science. Thank you so much for tuning in to the Archive Radio Show today. Have a beautifully fantastic Thursday, and I will see you all next time. Goodbye for now, and take care.